Question 1. What is ETL and why is it important in real-world data systems? Explain with a practical example. Answer. ETL stands for extract, transform, and load, and it is the fundamental process used to move data from operational systems into analytical systems like data warehouses. In real-world companies, data is generated across many tools, such as CRM systems for customers, HRMS for employees, POS systems for sales, and finance tools for billing. Each of these systems stores data in its own format and structure, which is not directly suitable for analytics or reporting. The extract phase focuses on pulling data from these source systems. This could be done through REST APIs, database queries, flat files like CSVs, or event streams. The goal here is not to modify data, but to retrieve it reliably and consistently. The transform phase is the most critical part of ETL. This is where raw data is cleaned, standardized, validated, and aligned with business rules. For example, dates may come in different formats, currencies may need normalization, duplicate records must be removed, and missing values must be handled carefully. Business logic such as active customer, valid transaction, or current employee is applied at this stage. Finally, the load phase stores the transformed data into a target system such as a data warehouse, where it can be used for dashboards, reporting, and AI models. Data is usually loaded into well-designed tables like facts and dimensions to support fast querying. A practical example would be extracting sales data from a POS system, transforming it by removing duplicates and correcting timestamps, and loading it into a warehouse where finance and leadership teams can track daily revenue. ETL is important because without it, organizations would be making decisions based on inconsistent, unreliable, or incomplete data. Question 2. Why is Python commonly used for data integration and ETL pipelines instead of other programming languages? Answer. Python is widely used for data integration because it strikes a very good balance between simplicity, power, and flexibility. In data engineering, pipelines often need to connect to many different systems, APIs, databases, file systems, and cloud services, and Python has mature libraries for all of these use cases. One major advantage of Python is its readability. ETL pipelines are long-running systems that evolve over time. Readable code makes maintenance easier and reduces the risk of errors when pipelines are modified months or years later. Libraries like Pandas make data transformations intuitive, while Requests simplifies API communication and Sclalchemy helps with database interactions. Python also has strong error handling and logging capabilities, which are essential for production systems. When a pipeline fails at 2 a.m., logs need to clearly explain what went wrong and where. Python supports this very well. Another key reason is Python's strong ecosystem and community. New data tools, cloud services, and integrations usually provide Python SDKs first. This allows engineers to quickly adapt pipelines as business requirements change. Overall, Python is not just a scripting language in this context. It is a reliable backbone for building scalable, maintainable, and production-grade data pipelines. Question 3. How do you read and process very large CSV files efficiently in a production data pipeline? Answer. In production systems, large CSV files can easily be several gigabytes in size, and loading them entirely into memory is risky and inefficient. To handle this properly, I use a chunk-based processing approach, where the file is read and processed in smaller batches instead of all at once. Using chunking allows the pipeline to process a fixed number of rows at a time, apply transformations, and load each batch into the target system before moving to the next one. This keeps memory usage stable and predictable, even for very large files. In addition to chunking, I optimize performance by explicitly selecting only the required columns and defining data types upfront wherever possible. This avoids unnecessary memory usage and reduces parsing overhead. If the data is being loaded into a database or a warehouse, each chunk is committed independently, which also improves fault tolerance. This approach not only prevents memory crashes, but also makes the pipeline restartable. If the job fails halfway, it can resume from the last successful batch instead of starting from scratch. Efficient file handling like this is essential for building reliable and scalable data integration pipelines. Question 4. What is idempotency in data pipelines, and why is it critical in production environments? Answer. Idempotency in data pipelines means that running the same pipeline multiple times with the same input data will always produce the same final result. This concept is extremely important in real production environments because failures are not exceptions, they are expected. In real-world data systems, pipelines can fail due to network issues, API timeouts, database locks, or infrastructure problems. When this happens, the pipeline often needs to be retried. If the pipeline is not idempotent, retries can create duplicate records, inconsistent metrics, or corrupted tables, which leads to loss of trust in data. To achieve idempotency, I avoid blind inserts and instead rely on business keys and upsert logic. For example, when loading data into a warehouse, I use merge operations where records are matched on a unique identifier such as transaction ID, customer ID, or employee ID. If a record already exists, it is updated. If it doesn't, it is inserted. I also use checkpoints, such as the last process timestamp or ID, so the pipeline knows exactly where to resume after a failure. Idempotency ensures that pipelines are safe to rerun, easy to recover, and reliable over time. In short, idempotency is what separates experimental pipelines from production-grade systems. Question 5. How do you handle missing, null, or incomplete data in an ETL pipeline? Answer. Handling missing or incomplete data is one of the most common challenges in data integration, and there is no single rule that works for all cases. My first step is always to understand the business meaning of the data, because the way missing values are handled can directly impact reporting and decisions. For some fields, missing values may be acceptable. For example, optional customer metadata might be allowed to be null. In such cases, I leave the data as is, but make sure downstream systems are aware of it. For critical fields like IDs, dates, or monetary values, missing data usually indicates a data quality issue and must be handled carefully. Depending on the scenario, I may fill missing values with defaults defined by business rules, forward fill or backward fill values when it makes logical sense, drop records that are unusable or invalid, flag records, and send them to a separate quarantine table for review. I also ensure that all missing data handling logic is consistent and documented, so the same assumptions are applied across reports and analytics. The key principle is that missing data should never be silently ignored. It should be handled consciously and transparently. Question 6. How do you implement logging and monitoring in data pipelines, and why is it important? Answer. Logging and monitoring are essential because data pipelines usually run automatically and without human supervision. If something goes wrong, logs and monitoring systems are the only way to understand what happened and how to fix it. In my pipelines, I implement logging at every important stage. This includes logging when a job starts and finishes, how many records were read, transformed, and loaded, and whether any records were rejected due to validation errors. I also log meaningful error messages when exceptions occur, instead of generic failures. Monitoring builds on top of logging. I track key metrics such as pipeline success rate, runtime duration, and data freshness. Alerts are configured so that failures or SLA breaches are immediately visible to the team. This allows issues to be addressed before stakeholders even notice a problem. Good logging and monitoring reduce debugging time, improve reliability, and build confidence in the data. A pipeline without monitoring may work today, but it will eventually fail silently, and that is far more dangerous than a visible failure. Question 7. How do you handle failures in an ETL or data integration pipeline? Answer. Failures in data pipelines are inevitable, so the real question is not whether failures will happen, but how well the system is prepared to handle them. When designing ETL pipelines, I always assume that failures will occur and build safeguards accordingly. The first thing I do is clearly separate the pipeline into logical stages, such as extraction, transformation, and loading. If a failure occurs at any stage, downstream steps are immediately stopped to prevent partial or corrupt data from flowing into analytic systems. I use structured error handling with meaningful logging so that failures are easy to diagnose. In addition, I design pipelines to be restartable by using checkpoints, such as the last successfully processed timestamp or record ID. This allows the pipeline to resume from where it left off instead of reprocessing everything. After recovering from a failure, I always investigate the root cause and add preventive measures such as better validation, retries, or alerts. Handling failures well is crucial because silent or poorly managed failures quickly destroy trust in data. Question 8. What is data validation in ETL pipelines, and what types of validations do you commonly implement? Answer. Data validation is the process of ensuring that incoming data meets expected quality and correctness standards before it is loaded into downstream systems. Without proper validation, even a technically successful pipeline can produce misleading or incorrect results. In practice, I implement several types of validations. These include null checks for mandatory fields, range checks for numerical values, format checks for dates and identifiers, and duplicate detection to prevent double counting. For relational data, I also check referential integrity to ensure foreign keys align with dimension tables. Validation is not just about rejecting bad data. It is also about visibility. When invalid records are found, I log them clearly and often store them in a separate quarantine table so they can be reviewed and corrected if needed. Strong validation protects the integrity of analytics and ensures stakeholders can trust the numbers they see. Question 9. What is the difference between where and having in SQL, and when should each be used? Answer. The difference between where and having comes down to when the filtering happens in a SQL query. The where clause filters individual rows before any aggregation takes place, while the having clause filters results after aggregation has been applied. I use where when I want to reduce the dataset early, such as filtering records by date, status, or category before grouping them. This is generally more efficient because it reduces the amount of data being processed. Having is used when the filtering condition depends on aggregated values, such as total sales greater than a certain amount or customers with more than a specific number of transactions. Understanding this distinction is important for both correctness and performance when writing SQL for data pipelines.
Question 10.
How do you identify and handle duplicate records in a database or data warehouse? Answer. Duplicate records are a common problem in data integration, especially when data comes from multiple systems or incremental loads. Identifying duplicates usually starts with understanding the business key, the set of fields that uniquely identify a real-world entity. To detect duplicates, I often use SQL queries that group records by the business key and look for counts greater than 1. For handling duplicates safely, especially in production, I prefer using window functions like row_number. This allows me to rank records within each group and keep the most recent or most valid record based on a timestamp or version field. Once duplicates are removed, I take steps to prevent them from reappearing. This may include enforcing unique constraints, improving idempotency logic, or fixing issues in upstream data sources. Duplicate handling is not just a cleanup task, it's part of maintaining long-term data reliability. Question 11. What is the difference between a primary key and a unique key, and how are they used in data systems? Answer. A primary key and a unique key are both used to enforce uniqueness in a table, but they serve slightly different purposes and have different constraints. A primary key uniquely identifies each record in a table and cannot contain null values. It represents the most reliable way to identify a real-world entity, such as a customer ID, employee ID, or transaction ID. In data pipelines, primary keys are critical because they are often used for joins, upserts, and maintaining data integrity. A unique key also enforces uniqueness, but depending on the database system, it may allow null values. Unique keys are often used for alternate identifiers such as email addresses or usernames, where uniqueness is required but the field is not the main identifier. In data integration, understanding this difference is important because primary keys are usually used for idempotent loading and merge operations, while unique keys help catch data quality issues such as duplicate emails or duplicate external IDs. Question 12. What are SQL window functions, and why are they important in data engineering? Answer. Window functions are SQL functions that perform calculations across a set of related rows while still returning individual rows in the result set. Unlike aggregate functions, window functions do not collapse rows into a single result, which makes them extremely powerful for analytics and data transformation. In data engineering, window functions are commonly used for tasks like deduplication, ranking, running totals, and identifying the latest record. For example, when removing duplicates, I can use row_number, partitioned by a business key and ordered by an update timestamp to identify which record to keep. Window functions are important because they allow complex transformations to be done directly in SQL in a clear and efficient way. They reduce the need for multiple queries or intermediate tables and are essential for writing clean, production-quality SQL. Question 13. How do you optimize slow SQL queries in a data pipeline? Answer. When a SQL query is slow, my first step is to understand why it is slow rather than immediately trying random optimizations. I start by looking at the query logic and identifying whether unnecessary data is being processed. One of the most effective optimizations is filtering data as early as possible using the where clause. Reducing the number of rows before joins or aggregations significantly improves performance. I also avoid selecting unnecessary columns and make sure joins are done on indexed or well-partitioned columns. If available, I review the query execution plan to understand where time is being spent. In data warehouses, I also leverage partitioning and clustering to minimize data scans. Query optimization is not just about speed. It also helps control compute costs and ensures pipelines scale as data grows. Question 14. What is a common table expression (CTE) and when do you use it? Answer. A common table expression, or CTE, is a temporary result set defined within a SQL query using the with clause. It allows complex queries to be broken down into smaller, logical steps, making them easier to read, understand, and maintain. I use CTEs when dealing with complex transformations that involve multiple joins, aggregations, or filtering stages. Instead of writing a single large query that is hard to debug, CTEs allow me to structure the logic step by step. CTEs are especially useful in data pipelines because they improve clarity and reduce the risk of mistakes. While they may not always offer performance benefits, they significantly improve maintainability, which is critical in long-running production systems. Question 15. What is incremental loading, and why is it preferred over full loading in most production pipelines? Answer. Incremental loading is the process of loading only new or updated records since the last pipeline run, rather than reloading the entire dataset every time. This is usually done using timestamps, version numbers, or incremental IDs. Incremental loading is preferred in production because it is faster, more scalable, and more cost-efficient. As data volumes grow, full reloads become increasingly expensive and slow. Incremental pipelines reduce processing time and minimize load on both source systems and the data warehouse. Additionally, incremental loading enables near real-time or frequent updates, which is often required for business reporting. Most mature data pipelines rely on incremental logic to operate reliably at scale. Question 16. When would you choose a full load instead of an incremental load? Answer. Although incremental loading is preferred in most cases, there are situations where a full load is the better choice. One common scenario is during initial pipeline setup, when historical data needs to be loaded for the first time. Full loads are also useful during backfills, major schema changes, or when data corruption has occurred and a clean reload is required. In some cases, if the dataset is very small or changes infrequently, a full load may be simpler and perfectly acceptable. The key is to make this decision based on data size, business impact, and operational cost rather than using a one-size-fits-all approach. Question 17. How do you integrate data from multiple source systems like CRM, HRMS, and POS? Answer. When integrating data from multiple systems, I treat each source independently because each has different data behavior and reliability characteristics. CRM systems are event-driven and change frequently. HRMS systems change slowly and require high accuracy, and POS systems generate large volumes of transactional data. I design separate ingestion pipelines for each system and normalize the data into a consistent structure during the transformation phase. Common business keys are identified so data can be joined correctly downstream. I also apply system-specific validation rules to ensure data quality. This modular approach keeps pipelines manageable and allows issues in one system to be isolated without affecting others. Question 18. How do you handle schema changes in source systems? Answer. Schema changes are inevitable in real-world systems. To handle them, I first ensure that pipelines can detect schema changes rather than failing silently. When a new column appears or an existing column changes type, the pipeline logs the change clearly. I then apply backward-compatible changes whenever possible, ensuring that existing reports and analytics are not broken. All schema changes are tested in a staging environment before being promoted to production. Proper schema handling reduces downtime and surprises for downstream users. Question 19. How do you ensure consistency between source data and data warehouse tables? Answer. Consistency is ensured through reconciliation and validation checks. I compare row counts between source and target systems, validate key metrics, and check for unexpected discrepancies. For critical pipelines, I also use checksums or aggregated comparisons to ensure data has not been altered incorrectly. Consistency checks are essential for maintaining trust and catching issues early. Question 20. What makes a data pipeline reliable and production-ready? Answer. A reliable, production-ready pipeline is one that works correctly not just once, but every day under real-world conditions. It is idempotent, meaning it can be safely retried. It has strong logging and monitoring so failures are visible and actionable. It also includes data validation, security controls, and clear documentation. Most importantly, a production-ready pipeline is designed with the assumption that things will go wrong and has mechanisms to recover quickly when they do. Question 21. How do you work with REST APIs when building data integration pipelines? Answer. When working with REST APIs in data integration pipelines, my first focus is reliability rather than speed. APIs are external systems, and they're often the least predictable part of a pipeline. I begin by understanding the API documentation, including authentication methods, rate limits, pagination style, and response formats. In implementation, I use proper authentication mechanisms such as API keys, OAuth tokens, or bearer tokens, and I make sure credentials are stored securely. I structure API calls so they are modular and easy to retry if something fails. Responses are usually in JSON format, so I carefully parse and validate the fields before processing further. I also design API ingestion to handle failures gracefully. Transient issues such as network errors or temporary rate limits are handled using retries and backoff strategies. Overall, my goal is to make API ingestion predictable and resilient, even when the API itself is unstable. Question 22. How do you handle pagination when extracting large datasets from APIs? Answer. Most APIs limit the number of records returned in a single response, which makes pagination unavoidable for large datasets. Pagination can be implemented using page numbers, offsets, cursors, or next page tokens, depending on the API design. To handle pagination, I design a loop that continues fetching data until there are no more pages left. I track pagination state carefully to ensure no records are skipped or duplicated. If the pipeline fails midway, pagination state is saved so the job can resume instead of starting over. Pagination handling must be robust because mistakes here can silently lead to missing data. That's why I also validate record counts and timestamps after extraction to ensure completeness. Question 23. How do you handle API rate limits and throttling? Answer. API rate limits are a common constraint in data integration, especially when working with SaaS tools like CRM or HRMS systems. Ignoring rate limits can lead to blocked access or incomplete data extraction. To handle this, I respect the documented rate limits and implement controlled request pacing. When limits are exceeded, I use retry mechanisms with delays or exponential backoff rather than immediately retrying requests. I also monitor API usage and failures so that rate limit-related issues are visible early. In some cases, I coordinate with API providers to request higher limits if the business need justifies it. Handling rate limits properly ensures long-term stability and avoids damaging integrations. Question 24. What is a staging layer, and why is it important in data pipelines? Answer. A staging layer is an intermediate storage area where raw or lightly processed data is stored before final transformations and loading into analytics tables. Its primary purpose is to act as a buffer and safety net between source systems and the data warehouse. By storing data in a staging layer, I can reprocess data without repeatedly pulling it from source systems, which reduces load and dependency on external tools. It also makes debugging much easier because I can inspect exactly what data was received at a given point in time. Staging layers also help decouple ingestion from transformation. This separation improves pipeline reliability and makes changes safer, especially when business logic evolves. Question 25. What is late-arriving data, and how do you handle it in data pipelines? Answer. Late-arriving data refers to records that arrive after the time window in which they were expected. This is common in systems like POS or distributed applications where network delays or retries occur. To handle late-arriving data, I design pipelines to rely on event timestamps rather than load timestamps. I also allow reprocessing windows where recent historical data can be updated safely. This approach ensures that reports and analytics remain accurate even when data does not arrive in perfect order. Handling late-arriving data properly is critical for maintaining trust in time-based metrics. Question 26. How do you handle backfills in a production data pipeline? Answer. Backfills are used to load or reload historical data, usually due to missing data, schema changes, or new business requirements. I treat backfills as controlled operations, separate from regular daily pipelines. Backfill jobs are parameterized by date ranges and executed carefully to avoid overwhelming source systems or warehouses. I ensure pipelines are idempotent so historical data can be safely overwritten or updated. After a backfill, I validate results thoroughly to confirm consistency with existing data. Poorly managed backfills can cause more harm than good, so discipline and testing are essential. Question 27. What is the difference between raw, staging, and curated data layers? Answer. The raw layer stores data exactly as it comes from source systems, with minimal or no transformation. It acts as a historical record and recovery point. The staging layer cleans and standardizes the data, fixing formats, aligning schemas, and applying basic validations. The curated layer contains business-ready data optimized for analytics, reporting, and AI use cases. This layered approach improves reliability, traceability, and maintainability. Question 28. Why is separating ingestion and transformation important? Answer. Separating ingestion from transformation reduces complexity and risk. Ingestion focuses on reliably getting data into the system, while transformation focuses on applying business logic. This separation makes pipelines easier to debug, safer to modify, and more resilient to change. It also allows ingestion to continue even if transformation logic needs updates. Question 29. How do you handle schema drift in real-world data sources? Answer. Schema drift occurs when source systems add, remove, or change fields over time. To handle this, I design pipelines that detect schema changes and log them clearly. Whenever possible, I apply backward-compatible changes, so existing pipelines continue to work. Schema changes are tested in staging before production deployment to avoid breaking reports. Question 30. How do you ensure data pipelines are restartable and recoverable? Answer. Restartability is achieved through checkpoints, incremental processing, and idempotent logic. Pipelines store progress, so they know where to resume after failure. This design minimizes downtime and avoids full reloads. Recoverable pipelines are a hallmark of mature, production-grade data systems. Question 31. How do you safely remove duplicate records while keeping the most recent or correct version? Answer. Safely removing duplicates starts with clearly identifying the business key that defines uniqueness, such as a customer ID, employee ID, or transaction ID. Once the business key is defined, I use additional fields like update timestamps or version numbers to determine which record should be kept. In SQL-based systems, I commonly use window functions such as row_number, partitioned by the business key and ordered by the update timestamp in descending order. This allows me to rank records within each group and keep only the most recent or most valid record. Before deleting or overwriting data, I always validate results in a staging environment. Deduplication logic must be deterministic and repeatable because incorrect deduplication can permanently distort metrics and erode trust in the data. Question 32. When and why would you use a merge statement instead of insert or update? Answer. I use a merge statement when data can be both inserted and updated, which is very common in incremental pipelines. A merge allows me to match incoming records with existing records using a business key, and then decide whether to update existing rows or insert new ones. This approach is essential for idempotent pipelines. If the pipeline is rerun, merge ensures that records are not duplicated and that updates are applied consistently. Compared to separate insert and update statements, merge reduces complexity and improves reliability. In production systems, merge is often the safest way to keep warehouse tables synchronized with changing source data. Question 33. How do you validate that data was loaded correctly into the target system? Answer. Validation begins by comparing row counts between source and target systems to ensure completeness. I also validate key metrics such as totals, averages, or distinct counts, especially for business-critical data. For sensitive or high-impact pipelines, I use additional checks like checksum comparisons or aggregated validations by date or category. Any discrepancies are logged and investigated immediately. Validation is not a one-time task. It is built into pipelines so that every run produces confidence, not just data. Question 34. What are slowly changing dimensions, SCD, and why are they important? Answer. Slowly changing dimensions refer to techniques used to manage changes in dimension data over time. Dimensions such as employees, customers, or products often change. For example, an employee's role or department may be updated. SCDs allow these changes to be handled correctly without losing historical context. The most common approach, Type 2 SCD, creates a new record whenever a change occurs while preserving the old version. SCDs are important because analytics often depend on historical accuracy. Without SCDs, reports can incorrectly apply today's attributes to past events. Question 35. Why is SCD particularly important for HRMS data? Answer. HRMS data contains attributes such as salary, role, department, and manager, which change over time. Business analysis often requires understanding how these attributes looked at a specific point in history. Using SCDs ensures that historical reports remain accurate. For example, when analyzing payroll costs or headcount trends, it is important to reflect the employee's role and salary at that time, not their current details. Because HRMS data is sensitive and compliance-driven, accuracy and traceability are especially critical. Question 36. How do you make a data pipeline restartable after failure? Answer. A restartable pipeline tracks its progress using checkpoints, such as the last process timestamp, file offset, or record ID. If a failure occurs, the pipeline resumes from the last checkpoint instead of starting over. Restartability also requires idempotent logic, so reprocessing data does not create duplicates or inconsistencies. Together, checkpoints and idempotency allow pipelines to recover quickly and safely. Question 37. How do you handle schema drift in production pipelines? Answer. Schema drift happens when source systems add, remove, or change fields unexpectedly. To handle this, I design pipelines that detect schema changes automatically and log them clearly. When changes are backward compatible, I adapt transformations without breaking downstream systems. For breaking changes, I coordinate with stakeholders, update schemas carefully, and test thoroughly before deployment. Handling schema drift proactively reduces outages and surprises. Question 38. How do you manage configuration in data pipelines? Answer. Configuration values such as database connections, API endpoints, and file paths are externalized using configuration files or environment variables. This avoids hard-coding and makes pipelines easier to deploy across environments. Proper configuration management improves security, flexibility, and maintainability. Question 39. How do you secure sensitive data in data pipelines? Answer. Sensitive data is protected using encryption, access control, and masking. Pipelines follow the principle of least privilege, ensuring that only authorized systems and users can access sensitive fields. Logs are carefully designed to avoid exposing confidential information. Security is treated as a core design requirement, not an afterthought. Question 40. How do you test data pipelines before deploying them to production? Answer. Testing includes validating transformations with sample data, checking edge cases, and running end-to-end tests in a staging environment. I also verify performance and failure scenarios. Testing ensures pipelines behave predictably under real-world conditions and reduces the risk of production incidents. Question 41. How do you handle API version changes in long-running data integration pipelines? Answer. API version changes are inevitable, especially when working with SaaS platforms like CRM or HRMS tools. To handle this safely, the first thing I do is never tightly couple my pipeline logic to a single API version without abstraction. I isolate API-specific logic into separate modules so that if an API version changes, I only need to update one part of the pipeline instead of rewriting everything. When a new version is announced, I test it in parallel with the existing version in a staging environment and compare outputs to ensure consistency. I also pay close attention to deprecated fields, changed data types, or modified pagination behavior. Once the new version is validated, I roll it out gradually and monitor closely. This approach ensures continuity while minimizing risk to production pipelines. Question 42. What are webhooks, and when would you use them instead of polling APIs? Answer. Webhooks are event-driven mechanisms where a source system pushes data to your system when something happens, instead of your pipeline repeatedly polling the source for updates. This makes them highly efficient for near real-time use cases. I use webhooks when low latency is required and the source system supports reliable event delivery. For example, CRM systems may send webhook events when a lead is created or updated. These events can then trigger ingestion pipelines immediately. However, webhooks require careful handling, including retries, validation, and idempotency, because events can arrive out of order or be duplicated. When designed properly, webhooks significantly reduce API load and improve freshness. Question 43. How do you decide between batch processing and streaming ingestion? Answer. This decision is always driven by business requirements, not technology trends. I ask questions such as, does the business need this data immediately? What happens if the data is delayed by a few hours? How large is the data volume? For systems like HRMS or finance, batch processing is usually sufficient and much simpler to maintain. For POS transactions or real-time dashboards, streaming or near real-time ingestion may be required. Streaming systems introduce operational complexity, so I only recommend them when the business value clearly justifies it. Simpler solutions are often more reliable. Question 44. What data quality checks do you consider mandatory in production pipelines? Answer. At a minimum, I always implement checks for null values in mandatory fields, duplicate detection, range validation for numeric fields, and schema validation. These checks prevent the most common and damaging data issues. For critical pipelines, I also include referential integrity checks and anomaly detection on key metrics. Data quality checks are not about perfection, they are about catching issues early and preventing bad data from spreading. Question 45. How do you monitor data pipelines in production? Answer. Monitoring involves tracking both technical health and data health. On the technical side, I monitor job success rates, runtimes, and failure counts. On the data side, I track freshness, row counts, and validation results. Alerts are configured for failures and SLA breaches, so issues are visible immediately. Effective monitoring ensures problems are addressed proactively rather than discovered by end users. Question 46. What is data reconciliation and why is it important? Answer. Data reconciliation is the process of ensuring that data in the warehouse accurately reflects data from source systems. This typically involves comparing row counts, aggregates, or key metrics between source and target. Reconciliation is important because it builds trust. Without reconciliation, discrepancies may go unnoticed and silently affect reports and decision-making. Regular reconciliation acts as a safety net for complex pipelines. Question 47. How do you prioritize pipeline failures when multiple issues occur at the same time? Answer. I prioritize failures based on business impact, not technical complexity. Pipelines that affect revenue, compliance, or executive reporting come first. Less critical pipelines are addressed afterward. Clear communication is essential. I keep stakeholders informed about impact and expected resolution times so priorities are aligned. Question 48. How do you handle conflicting requirements from different stakeholders? Answer. When requirements conflict, I focus on understanding the underlying business goals rather than treating it as a technical argument. I clearly explain trade-offs, risks, and long-term implications of different approaches. Often, the best solution is a compromise that balances speed, accuracy, and maintainability. Transparent communication builds trust and leads to better decisions. Question 49. What is the biggest mistake teams make in data integration projects? Answer. The biggest mistake is assuming that source data is clean and stable. In reality, data is messy, incomplete, and constantly changing. Teams that ignore data quality, validation, and monitoring often face repeated incidents and loss of trust. Successful data integration projects treat data quality as a first-class concern, not an afterthought. Question 50. What makes a data pipeline truly production-ready? Answer. A production-ready pipeline is one that is reliable, observable, secure, and recoverable. It can be safely retried, monitored continuously, and recovered quickly after failure. Most importantly, it consistently produces correct data that stakeholders trust. Production readiness is not about complexity, it is about discipline and thoughtful design. Question 51. How would you design an end-to-end data integration architecture for CRM, HRMS, and POS systems? Answer. When designing an end-to-end data integration architecture, I start by acknowledging that CRM, HRMS, and POS systems behave very differently, so they should not be forced into a single ingestion pattern. I design separate ingestion pipelines for each system. CRM data is usually event-driven and frequently updated, so I use incremental API-based ingestion. HRMS data changes slowly but is sensitive, so I prefer scheduled batch ingestion with slowly changing dimensions to preserve history. POS data is high volume and transactional, so I design append-only ingestion, often partitioned by transaction date. All data first lands in a raw layer, where it is stored exactly as received. This gives me traceability and the ability to reprocess data if something goes wrong. From there, data moves into a staging layer, where cleaning, normalization, and validation happen. Finally, curated warehouse tables are built for analytics, reporting, and AI use cases. Monitoring, logging, and reconciliation are built into every stage. This layered approach keeps the system modular, scalable, and resilient to change. Question 52. How do you design data pipelines to scale as data volume grows over time? Answer. Scalability in data pipelines is less about adding more compute and more about reducing unnecessary work. My first strategy is to avoid full reloads and rely on incremental processing wherever possible. I also design pipelines to process data in partitions, usually based on time, such as date or hour or business keys. Partitioning ensures that queries and transformations only touch the data they actually need. Parallel processing is another key factor. Independent partitions can be processed simultaneously, which improves throughput without complicating logic. Finally, I continuously monitor performance metrics and refactor bottlenecks before they become serious issues. Scalable pipelines are proactive, not reactive. Question 53. How do you handle very high-volume POS transaction data efficiently? Answer. POS data is typically high-volume, append-heavy, and time-sensitive. To handle this efficiently, I design pipelines that treat POS transactions as immutable events. Once a transaction is recorded, it is rarely changed, which simplifies processing. I partition POS data by transaction date or store location to reduce query scans and improve load performance. Ingestion is done in microbatches or near real time, depending on business needs. Late-arriving transactions are handled using event timestamps and controlled reprocessing windows. Accuracy and reconciliation are critical for POS data, so I validate totals against finance systems to ensure consistency. Question 54. How do you manage dependencies between multiple pipelines and downstream systems? Answer. Pipeline dependencies are managed by clearly defining upstream and downstream relationships. Each pipeline explicitly declares what it depends on and what it produces. I ensure that downstream transformations only run after upstream ingestion completes successfully. If an upstream dependency fails, downstream jobs are automatically blocked to prevent partial data exposure. This approach avoids cascading failures and ensures that analytics always work with complete and consistent data. Question 55. How do you handle data that arrives out of order from distributed systems? Answer. Out-of-order data is common in distributed systems due to retries, network delays, and asynchronous processing. To handle this, I rely on event timestamps rather than load timestamps when processing data. I design pipelines with reprocessing windows so that recent historical data can be updated safely. This ensures that late or out-of-order events are incorporated correctly without rewriting large amounts of data. This approach maintains accuracy while keeping pipelines efficient. Question 56. How do you design fact and dimension tables in a data warehouse? Answer. Fact tables store measurable business events, such as sales transactions or user activity. Dimension tables store descriptive attributes, such as customers, products, or employees. I design fact tables to be narrow and optimized for aggregation, while dimension tables are designed for readability and reuse. This star schema approach improves query performance and makes analytics easier for end users. Question 57. How do you handle updates and corrections in fact tables? Answer. Although fact tables are often append-only, corrections do occur. I handle updates using controlled merge operations that update only affected records. For auditability, I may track corrections separately or store adjustment records rather than overwriting data blindly. This ensures transparency and traceability. Question 58. What is partitioning and why is it important in large data warehouses? Answer. Partitioning divides large tables into smaller, manageable segments based on a key such as date. This significantly reduces query scan size and improves performance. Partitioning also helps with maintenance tasks like backfills and data retention. It is one of the most effective techniques for scaling large datasets. Question 59. What is clustering, and when would you use it? Answer. Clustering organizes data within partitions based on frequently queried columns. It improves performance for filters and joins that use those columns. I use clustering when query patterns are predictable and data volumes are large enough to justify it. Question 60. How do you optimize warehouse cost without sacrificing performance? Answer. Cost optimization starts with efficient query design and incremental processing. I avoid unnecessary recomputation, archive and use data, and tune queries to reduce scans. Performance and cost are closely related. Well-designed pipelines usually optimize both naturally. Question 61. How do you design idempotent data pipelines, and why is idempotency critical in production systems? Answer. Idempotency means that running the same pipeline multiple times with the same input data produces the same final output. This is critical in production because retries are unavoidable. Pipelines fail due to network issues, API timeouts, infrastructure restarts, or dependency failures, and when they do, they must be safely rerun. To design idempotent pipelines, I rely on stable business keys and upsert logic rather than blind inserts. For example, when loading data into a warehouse, I use merge operations keyed on identifiers like transaction ID, customer ID, or employee ID. If a record already exists, it gets updated. If not, it is inserted. I also track processing checkpoints, such as the last process timestamp or sequence number. This allows the pipeline to resume accurately after a failure. Idempotency ensures data correctness, prevents duplication, and makes recovery predictable. Without it, even small failures can permanently damage data trust. Question 62. How do you handle partial failures in a multi-step data pipeline? Answer. Partial failures occur when one stage of a pipeline succeeds but a later stage fails. For example, data is extracted and transformed, but the load step fails midway. These are particularly dangerous because they can leave systems in an inconsistent state. To handle this, I design pipelines with clear stage boundaries and ensure that downstream steps do not run unless upstream steps complete successfully. I use transactional or atomic loading techniques where possible, so incomplete writes can be rolled back or safely retried. I also design pipelines to restart from checkpoints, not from scratch. After recovery, I always analyze the root cause and add safeguards such as better validation, retries, or monitoring. The goal is not just to recover, but to reduce the chance of the same failure happening again. Question 63. How do you manage secrets such as database passwords and API keys in production pipelines? Answer. Secrets management is a core security responsibility. I never hardcode credentials in source code or configuration files that are committed to version control. Instead, secrets are stored in secure locations such as environment variables, secret management services, or encrypted configuration stores, depending on the infrastructure. Pipelines retrieve secrets at runtime, ensuring they are not exposed unnecessarily. Access to secrets follows the principle of least privilege, meaning each pipeline only has access to what it strictly needs. I also make sure secrets are never printed in logs or error messages. Proper secrets management protects both the system and the organization. Question 64. How do you ensure security in data pipelines, especially when handling sensitive data like HRMS information? Answer. Security starts with understanding data sensitivity. HRMS data often includes personally identifiable information, so I apply stricter controls compared to less sensitive datasets. Data is encrypted both in transit and at rest. Access is restricted using role-based permissions, and sensitive fields are masked where full visibility is not required. Logs are carefully reviewed to ensure they never contain confidential information. Security is built into pipeline design, not added later. I also ensure compliance with internal policies and regulatory requirements. A secure pipeline protects not just data, but also organizational trust. Question 65. How do you deploy changes to data pipelines safely without disrupting production systems? Answer. Safe deployment is about minimizing risk. I never deploy changes directly to production without testing. All changes are first validated in a staging environment using realistic data volumes and edge cases. Once validated, changes are rolled out gradually, and I monitor key indicators such as job success rates, data freshness, and validation results immediately after deployment. If issues arise, I ensure there is a clear rollback strategy. This disciplined approach allows pipelines to evolve while maintaining stability. Question 66. How do you define and manage SLAs for data pipelines? Answer. SLAs, or service level agreements, define expectations around data freshness, availability, and accuracy. They align technical work with business needs. I work with stakeholders to understand how quickly data is needed and how accurate it must be. Based on this, I define measurable SLAs such as data available by 8 a.m. or pipeline success rate above 99%. SLAs are monitored continuously, and breaches are alerted and analyzed. Well-defined SLAs create clarity and accountability for both engineering and business teams. Question 67. How do you handle data corruption in a production pipeline? Answer. When data corruption is detected, my first priority is containment. I stop downstream pipelines to prevent corrupted data from spreading and notify stakeholders immediately. Next, I identify the scope of the corruption and isolate affected data. Because data is stored in raw or staging layers, I can reprocess clean data after fixing the root cause. Finally, I add preventive checks and monitoring to reduce the likelihood of similar issues in the future. Fast, structured response is key to maintaining trust. Question 68. How do you handle breaking schema changes from source systems? Answer. Breaking schema changes, such as removed fields or changed data types, can disrupt pipelines significantly. To handle them, I rely on early detection and clear communication. I test schema changes in staging environments and update transformations carefully to maintain backward compatibility when possible. If breaking changes are unavoidable, I coordinate with stakeholders and schedule deployments to minimize impact. Proactive schema management prevents surprise outages. Question 69. How do you audit data changes and maintain data lineage? Answer. Auditing and lineage help answer the question, where did this data come from, and how did it change? I maintain audit fields such as load timestamps, source identifiers, and change indicators. I also track transformations applied at each stage so data flow can be traced from source to analytics. This transparency is especially important for compliance, debugging, and trust. Question 70. How do you measure the overall health of data pipelines? Answer. Pipeline health is measured using a combination of technical and data metrics. These include success rates, runtime duration, data freshness, validation failures, and SLA adherence. Healthy pipelines are not just fast, they are predictable, reliable, and trusted. Monitoring these metrics helps identify issues early and continuously improve system stability. Question 71. How do you balance speed versus accuracy when building data pipelines? Answer. Balancing speed and accuracy is a common challenge in data engineering, but my general principle is that accuracy always comes first, especially for business-critical data. Fast but incorrect data is far more damaging than slightly delayed but trustworthy data. In practice, I start by understanding how the data will be used. If the data is used for executive reporting, finance, or compliance, I prioritize validation, reconciliation, and correctness even if it increases processing time. For exploratory analytics or internal dashboards, there may be room to optimize for speed once basic accuracy is ensured. Over time, I work on improving both by optimizing queries, using incremental processing, and parallelizing workloads. But I never compromise core data correctness just to meet aggressive timelines. Question 72. How do you handle high-pressure situations such as production pipeline failures? Answer. In high-pressure situations, the most important thing is to stay calm and structured. Panic leads to rushed decisions, which often make the problem worse. My first step is to assess the impact, which pipelines are affected, who is impacted, and how urgent the issue is. I communicate clearly with stakeholders so expectations are managed early. Then I focus on containment, stopping downstream jobs if necessary to prevent incorrect data from spreading. Once the immediate impact is controlled, I work methodically to identify the root cause and restore normal operations. After recovery, I document what happened and implement preventive measures. Handling pressure well is about discipline and communication, not heroics. Question 73. How do you explain technical trade-offs to non-technical stakeholders? Answer. When explaining trade-offs to non-technical stakeholders, I avoid deep technical details and focus on impact, risk, and outcomes. Instead of saying this query is expensive, I explain that it may slow down reports or increase costs. I present options clearly, outlining the benefits and downsides of each approach. For example, I might explain that a faster solution may be less accurate, while a slower solution provides more reliable insights. This allows stakeholders to make informed decisions based on business priorities. Clear communication builds trust and ensures that technical decisions align with business goals. Question 74. How would you approach improving an existing messy or unreliable data pipeline? Answer. When dealing with a messy pipeline, I resist the urge to rewrite everything immediately. Instead, I start by understanding how the pipeline currently works and where the biggest risks are. I prioritize fixes that improve data correctness and observability, such as adding logging, validation checks, and monitoring. Once the pipeline is stable and visible, I gradually refactor code, simplify transformations, and improve documentation. This incremental approach reduces risk and ensures improvements deliver value without disrupting existing users. Question 75. What differentiates a good data integration engineer from a great one? Answer. A good data integration engineer can build pipelines that move data from point A to point B. A great one thinks beyond that. Great engineers anticipate failures, design for recovery, and understand the business meaning of data. They care about long-term maintainability, data trust, and stakeholder confidence. Most importantly, they take ownership when data breaks. They don't just fix it, they prevent it from happening again. Question 76. How do you build trust in data across an organization? Answer. Trust in data is built through consistency and transparency. I ensure pipelines run reliably, data quality checks are visible, and issues are communicated proactively. When problems occur, I explain what happened, how it was fixed, and what is being done to prevent recurrence. Over time, this honesty builds confidence. People trust data when it behaves predictably and when engineers take responsibility for it. Question 77. How do you handle situations where business users report wrong numbers in dashboards or reports? Answer. When someone reports wrong numbers, I never assume they are mistaken. I treat it as a valid concern and investigate calmly. I start by understanding how the numbers are being used and what the expectation is. Then I trace the data from the dashboard back through transformations to the source systems. Often, the issue is a misunderstanding of definitions rather than a technical bug. Once identified, I fix the issue, communicate clearly, and update documentation or validation checks if needed. This approach strengthens trust rather than damaging it. Question 78. How do you design data models that support both analytics and AI use cases? Answer. For analytics and AI, data models must be consistent, historical, and well-structured. I design models that preserve history, especially for dimensions that change over time, so machine learning models can learn from past states accurately. I also standardize naming, data types, and units across datasets to reduce confusion and feature engineering effort. The goal is to make data intuitive and reliable so analysts and data scientists can focus on insights rather than cleanup. Question 79. How do you resolve conflicts when multiple systems provide different values for the same data? Answer. When conflicts arise, I first define the system of record for each data attribute. For example, HRMS is usually the source of truth for employee data, while CRM owns customer contact information. If conflicts persist, I apply clear business rules, such as preferring the most recently updated value or a trusted system. These rules are documented and communicated so decisions are transparent. Clear ownership prevents confusion and repeated disputes. Question 80. How do you write Python code that remains maintainable as pipelines grow over time? Answer. Maintainable Python code is written with the assumption that it will be read and modified by others. I keep code modular, break logic into reusable functions, and avoid hard-coding values. I add meaningful logging and comments that explain why something is done, not just what is done. I also follow consistent naming conventions and structure. Maintainable code reduces operational risk and makes pipelines easier to evolve as requirements change. Question 81. How do you manage and reduce technical debt in long-running data pipelines? Answer. Technical debt is almost unavoidable in data pipelines because requirements change, timelines are tight, and systems evolve. The real risk is not having technical debt, but ignoring it. I manage technical debt by first making it visible. I document known issues, shortcuts, or fragile parts of the pipeline so they are not forgotten. Then I prioritize debt based on risk to data correctness and reliability, not just code elegance. Anything that can cause incorrect data or production failures gets addressed first. Rather than attempting large rewrites, I prefer incremental improvements. For example, adding validation, refactoring a complex transformation, or improving logging step by step. This approach reduces risk and allows the pipeline to keep delivering value while steadily becoming more robust. Question 82. How do you ensure that business stakeholders trust the data produced by your pipelines? Answer. Trust is built over time through consistency, transparency, and communication. I ensure pipelines run reliably and produce predictable results. When issues occur, I communicate proactively instead of waiting for users to discover problems themselves. I also make data quality checks and limitations visible. For example, I clearly state data freshness, known gaps, or assumptions used in transformations. When stakeholders understand what the data represents and what it doesn't, trust increases. Most importantly, I take ownership. When data is wrong, I treat it as my responsibility to fix it and prevent it from happening again. That accountability is what ultimately builds confidence. Question 83. How do you respond when stakeholders report incorrect or inconsistent numbers in reports? Answer. When someone reports incorrect numbers, I approach the situation calmly and without defensiveness. I start by understanding what they expected to see and how they are using the data. This context is critical because many issues come from differing definitions rather than technical errors. Next, I trace the data lineage from the report back through the transformations to the source systems. This helps identify whether the issue is a logic bug, a data quality problem, or a misunderstanding. Once the root cause is identified, I explain it clearly, fix the issue if needed, and add validation or documentation to prevent similar confusion in the future. This process often strengthens relationships rather than damaging them. Question 84. How do you handle personally identifiable information, PII, and sensitive data in data pipelines? Answer. Handling PII responsibly is a critical part of data engineering. My approach is based on minimization, protection, and control. I ensure that sensitive data is only collected and stored when absolutely necessary. When it is required, I protect it using encryption both in transit and at rest. Access is strictly controlled using role-based permissions, and sensitive fields are masked or anonymized where full visibility is not needed. I also make sure that logs, error messages, and monitoring tools never expose PII. Responsible handling of sensitive data is not just a technical requirement, it's a matter of trust and compliance. Question 85. Describe a worst-case data pipeline failure scenario and how you would handle it. Answer. A worst-case scenario is when incorrect or corrupted data reaches production dashboards or downstream systems and begins influencing decisions. In such cases, speed and structure matter. My first step is containment, stopping downstream pipelines and clearly communicating the issue to stakeholders. Next, I identify the scope of the problem. What data is affected, how far it spread, and when it started. Once the root cause is fixed, I reprocess clean data from raw or staging layers and validate results thoroughly before re-enabling downstream systems. After recovery, I conduct a post-incident review and implement preventive measures. How a team handles failure matters more than the failure itself. Question 86. How do you design pipelines so they can recover quickly after failures? Answer. Fast recovery depends on restartability and isolation. I design pipelines with checkpoints so they can resume from the last successful state instead of starting over. I also isolate pipelines by source and function, so failures in one pipeline don't cascade into others. Idempotent logic ensures that retries don't introduce duplication or inconsistency. This design minimizes downtime and reduces operational stress during incidents. Question 87. How do you deal with ambiguous or unclear requirements when building data pipelines? Answer. Ambiguous requirements are common in data work. When this happens, I focus on clarifying intent rather than guessing. I ask targeted questions to understand how the data will be used and what decisions depend on it. If uncertainty remains, I propose assumptions explicitly and validate them with stakeholders before building full solutions. Sometimes I build a small prototype or sample dataset to align expectations early. This approach reduces rework and builds trust. Question 88. How do you communicate complex technical concepts to non-technical stakeholders? Answer. When speaking to non-technical audiences, I focus on impact and outcomes, not implementation details. I use simple language, analogies, and visuals when helpful. For example, instead of explaining a join or partition, I explain how data is grouped or filtered to answer a business question. Clear communication ensures alignment and prevents misunderstandings. Question 89. How do you prioritize tasks when multiple pipelines or issues demand attention at the same time? Answer. I prioritize based on business impact and risk. Pipelines that affect revenue, compliance, or executive reporting take precedence over internal or exploratory systems. I also communicate priorities clearly so stakeholders understand what is being addressed and why. This transparency reduces friction and builds confidence during busy periods. Question 90. Why did you choose to work in data integration and data engineering? Answer. I chose data integration because it sits at the intersection of systems, business, and analytics. I enjoy solving real-world problems where messy, fragmented data needs to be transformed into something reliable and meaningful. Knowing that the pipelines I build directly support decisions, reporting, and AI makes the work deeply satisfying. Data integration allows me to have tangible impact beyond just writing code. Question 91. Why should we hire you for this data integration engineer role? Answer. You should hire me because I bring a balance of strong fundamentals, production thinking, and ownership. I don't just focus on moving data from one system to another. I focus on making sure the data is correct, reliable, and trusted by the business. I understand that data pipelines run every day and failures are inevitable, so I design systems that are idempotent, observable, and recoverable. I communicate clearly with both technical and non-technical stakeholders, and I take responsibility when things go wrong instead of shifting blame. Most importantly, I care about long-term reliability. I build pipelines assuming someone else will depend on them for important decisions, and I treat that responsibility seriously. Question 92. What questions would you ask us at the end of the interview? Answer. At the end of an interview, I like to ask questions that help me understand how data is treated within the organization. For example, I might ask about the current state of data maturity, the biggest challenges the data team is facing, and how success is measured for this role. I also ask how teams collaborate across product, engineering, and analytics, because data integration often sits at the center of many functions. These questions show that I'm thinking long-term and that I care about building systems that truly support the business. Question 93. How do you handle feedback or criticism from peers or managers? Answer. I see feedback as an opportunity to improve, not as a personal attack. When I receive feedback, I listen carefully, ask clarifying questions if needed, and reflect on how I can apply it. If the feedback is valid, I act on it quickly and make changes. If I disagree, I still try to understand the perspective behind it and have a constructive discussion. Over time, this mindset helps me grow and strengthens team collaboration. Question 94. How do you keep yourself updated in the field of data engineering? Answer. I stay updated primarily through hands-on work. Real problems teach more than trends. I read documentation when working with new tools, follow engineering blogs, and learn from production incidents. I also review designs and postmortems from the community to understand how others solve similar problems. I focus on fundamentals like reliability, scalability, and data quality because tools change, but these principles remain constant. Question 95. What would you focus on in your first 30 days if you joined our team? Answer. In my first 30 days, my priority would be understanding the existing data ecosystem. I would learn the source systems, current pipelines, data models, and how stakeholders use the data. I would focus on stability before suggesting major changes. This includes reviewing monitoring, understanding SLAs, and identifying high-risk areas. Once I understand the system and the business context, I can start contributing improvements in a thoughtful and informed way. Question 96. How do you measure your own success as a data integration engineer? Answer. I measure my success by how reliable and trusted the data systems I own are. If pipelines run consistently, data quality issues are caught early, and stakeholders can make decisions without second-guessing the data, I consider that success. I also value reduced operational noise, fewer late-night incidents, fewer emergency fixes, and smoother day-to-day operations. Reliable systems reflect good engineering. Question 97. What do you think is the hardest part of data engineering? Answer. The hardest part of data engineering is dealing with imperfect and constantly changing data while still delivering reliable outcomes. Source systems evolve, requirements shift, and data is rarely as clean as expected. Balancing flexibility with stability requires experience and judgment. Technical skills matter, but mindset and discipline matter even more. Question 98. How do you stay calm and effective during critical incidents or outages? Answer. I stay calm by following a structured approach. First, I assess impact and contain the issue. Then I communicate clearly so everyone knows what's happening. Instead of rushing, I break the problem into smaller steps and solve it methodically. After recovery, I reflect on what went wrong and how to prevent it. Calmness comes from preparation and experience, not from ignoring pressure. Question 99. Where do you see yourself growing after this role? Answer. I see myself growing into a role where I can own larger data platforms and contribute to architectural decisions. I want to deepen my understanding of system design, reliability, and data governance. I'm interested in becoming someone who not only builds pipelines, but also helps shape how data is used across the organization. Question 100. Is there anything else you'd like us to know before we conclude? Answer. I would like you to know that I take ownership seriously. When I build or maintain a data pipeline, I consider it my responsibility to ensure it is correct, reliable, and understandable. I value clear communication, continuous improvement, and long-term thinking. If given the opportunity, I will treat your data systems with the same care and responsibility as if they were my own.